Hello everyone, this is Sandhya. I'm a data science enthusiast at Almabetter. So this is my capstone project, Applied Statics Interview Grant. The problem statement is, in this, we have to write solutions to any 50 questions out of the 80 total questions, and we need to describe or explain 5 questions for the video presentation. So let's have a look. So I have started the project from here, and these are the solutions to 50 interview questions. And so I have covered basically all the questions. And now I have selected 5 questions. So let's move to the video. Yeah. So what the first question is, how is a vector different from a scalar? First, we need to understand what is vector and what is scalar. So, both vector and scalar quantities, both are the physical quantity, right? So, physical quantity means the measurable and quantifiable physical property that carries unique information with it. So, based on the dependency of direction, physical quantities can be classified into two categories basically. The first one is the vector quantity, second is the scalar quantity. So the basic definition of vector and scalar and the basic difference between vector and scalar is scalar means that have only magnitude or size. For example, speed, mass, density, distance. Okay, no direction. But vector quantities are those physical quantities that have both magnitude as well as direction, like displacement, velocity, acceleration, force. So it should be noted that when a vector quantity changes, its magnitude and direction also changes. Like, and when a scalar quantity changes, only its magnitude changes. So have a look at this picture, scalar and vector. So scalar, as I told you, it has only magnitude. So it is showing 5 meter long. It's about a distance. And now come to the vector quantity. It's also talking about direction, 5 meter east. So this is the basic difference between scalar and vector. Now I have made the chart. In this chart, we can clearly see the difference. So the first thing is scalar quantities have magnitude or size only, as I already told, and vector have both magnitude as well as direction. And scalar quantity only exists in one dimension because of the magnitude or size, but vector quantities can exist in two or three dimensions. So whenever there is a change in scalar quantity, the magnitude also change. And whenever there is change in the vector quantity, the magnitude as well as the direction also change. Scalar quantities cannot be resolved into their components, while vector quantities can be resolved into their components, like using sine or cos of their adjacent angle. And any mathematical process that involve more than two scalar quantities will only give scalar, right? And the mathematical operations on two or more vectors can provide either a scalar or a vector as a result. The point should be noted that any mathematical process that involve more than two scalar quantities, it only gives scalar. But when it comes to the vector quantity, if we are performing any mathematical operation on two or more than two vectors, so it can either provide scalar or a vector as a result. Like the dot product of two vectors only produce a scalar, whereas the cross product, sum or subtraction of these, they provide vector. right? So the example of scalar quantities are mass, speed, distance, time, area, and volume. And the examples of vector quantities are velocity, force, pressure, displacement, and acceleration. So this is all about the difference between vector and scalar quantity. Now move to the second question I have chosen for the video presentation. This is probability. So what is probability theory? Basically, when we hear the probability for the very first time, only one thing that comes in our mind is something random. Okay, something related to the random phenomena, right? So basically, probability, it's a random phenomena that can have multiple outcomes, right? So let's move to the definition of probability. So probability theory makes the use of random variable and probability distribution to access uncertain situations mathematically. So let's have a look at the easiest part of the probability, which I have written by myself. So probability is simply how likely something is to happen. Like when we are unsure about the outcome of an event, we can talk about the probabilities of certain outcomes, like how likely they are. So probability basically means probability. So it's a branch of mathematics and statistics that deals with the occurrence of a random event, and the value is expressed from 0 to 1. So probability theory uses the concept of random variables and probability distribution to find the outcome of any situation, right? So probability theory is an advanced branch, like, that deals with odds and statistics of happening an event. But in real life, we can understand probability as a possibility that can have multiple or several outcomes, right? Or certain outcomes. So for example, the flip of coin, it's very familiar. That's why I'm giving you the example of flip of the coin. As soon as you flip the coin, the result is random, right? It may be tail, it may be head. Suppose I'm flipping the coin, but I cannot tell you the exact result. Okay, the exact result, what will come, whether it could be tail or it could be head. So this is what we call probability. So both head and tail, they will have the equal probability of landing. Means 50-50 chance. Okay. Thus we can say that probability of either head or either tail is 50-50. Right. So this is a quick definition about the probability. So below are the example. As you can see, the pictorial example of probability, flip of the coin as I told you, and the dice also. And if we move to the probability formula basically means the number of favorable outcome and the total number of possible outcome. Right. So suppose I'm flipping the coin. So favorable outcome could be head or tail. It could be head or it could be tail. So favorable outcome is 1, and total number of possible outcome is head plus tail 2. So the possibility or the probability will be 1 by 2. Means it could be either head, it could be either tail, but total outcome means head plus tail. Now let's move to the probability theory basics. Right. So there are some basics of the probability. First is the random experiment, because random means probability, as we already know that probability is something that is random. Okay. Or we can say it is a trial. Okay, that is repeated multiple times in order to get a well defined set of possible outcome. So tossing a coin, it's a familiar example. Then a sample space. So what is the sample space in probability? It means set of all possible outcome that result from conducting a random experiment. For example, the sample space of tossing a fair coin is head and tail, right? Then event of the probability theory defines there are several kind of event. right? It defines a set of outcome of the experiment from a subset of the sample space. So they're independent event, dependent, mutually exclusive, equally likely event, and exhaustive event. So basically, probability theory, it's about random experiment and its analysis of the random phenomena, and the outcome of a random event cannot be determined before it occurs. Okay, I'm flipping the coin, but I cannot determine that what will come exactly, but I can just make a probability that it might be head or it might be tail. Okay, but we can just focus on some possible outcomes, like it could be tail or it could be head. The outcome or the actual outcome is considered to be determined by chance. Okay, so basically probability is all about the uncertainty, and it can be defined as a branch of mathematics statistics that deal with the randomness and uncertainty in concrete situations. Now move to the third question. Third question is, what are some common measures of central tendency and how are they calculated? Basically, central tendency. What are the measures of central tendency? So, central tendency are the value that describe a data set by identifying the central position of the data. It is defined as that it can be used to represent the entire distribution or a data set using a single value. This is what we call measure of central tendency. So any of the measure of central tendency that provide an accurate description of the entire data. So basically the three measures of central tendency are there: mean, mode, median. Right? Mean, mode, median. These are the common measures of the central tendency. Let's understand with the help of diagrammatic representation of measures of central tendency. So, mean, mode, median, right? So, what is the mean? As we have the data set 734,176. So, if we want to calculate the mean, how we will calculate the mean? Basically, we will summing up all the values in the data set dividing by the number of total values. Like we are going to sum up 7 plus 3 plus 4 plus 1 plus 7 plus 6, and total number of values are the 6. This is what we call the mean. Means sum of all observation divided by the total number of observation. Second is the mode. Mode means most common value in a particular data set. So which is the most common value? As we can see, it's 7. It has repetition. So 7. Basically, mode is all about the redundancy of the particular number in the data set. So 7. The most frequent occurring value in a data set. And median. Median means middle or the central value in a order data set. Like first, what we need to do, we need to arrange the data set in a particular order, then pick the middle value. Suppose 1, 2, 3, 4, 5, 6. So if we are having 6 like even value, so what we will do, we will pick these two, 6 plus 4, and then by 2. So this is the median, the middle or central value in an ordered set. Now how mean as a measure of central tendency, how to calculate it? So basically this is the formula: mean is equals to sum of terms by number of terms. So x bar, it represents the sigma fx by sigma f. So sigma bar, it represents the mean value of this set of given data set. F means frequency of each class, and x is mid interval value of each class. Second is median as a measure of central tendency. Basically, the major advantage of using the median as a central tendency is that it is less affected by outliers and skewed data. So we can calculate the mean for different types of data such as group data, ungroup data, right? So this is the formula for the median. for group data, right? So in this, L is the lower number of median class, then C is the cumulative frequency, H is the class size, and is the number of observation and median class where n by 2 lies. Third is mode as a measure of central tendency. So mode is defined as the value which appear most often, as I already told you, which appears most often in the given data set. That is the observation with the highest frequency is called the mode of data. So this is the formula given, and in this, L is the lower limit of the model class, H is the size of the interval class, Fm is the frequency of the model class, F1 is the frequency of class preceding the model class, and F2 is the frequency of the class succeeding the model class. Now let's move to the next part. What is sampling in statics and why it is important? So I have my own explanation for the sampling. So basically, sampling means selecting the group that you will actually collect data from and in your research. Okay. A large population, and we are selecting a sample. So suppose if I am or if you are researching the opinions of students in your university, so you could survey a sample of 100 students, because in a university there are thousands or maybe lakhs, right? So we cannot go to each student, okay, to get the opinions of the student. So what we will do, we will take a sample of the student. Suppose we are taking as a sample of 100 student, so this is what we call sample is basically a technique of selecting the representative part of the population for the purpose of determining parameters or the characteristics of the whole population. The last line is saying that determining parameters or characteristics of the whole population. The sample we should choose wisely because it talks about and it tells about parameters or characteristics of the whole population. Yeah. So as this is the picture of the population, the whole population, and how we can take a sample, right? So, the method of sampling depends on the type of analysis being performed, but it may include simple random sampling or systematic sampling. So, sampling is commonly done in statics, not only in statics, psychology, and financial industry, right? So, basically, what happened when it is not possible for the researchers to conduct the accurate study because of the large population. So, what we do, we take a small sample from that particular population, right? And it is also impossible to study every individual from the group, right? That's why they often choose a small portion to represent the entire group. We are representing the entire group, as I have already given the example of college students. Okay. Sample allows researcher to use characteristics of the small group to make estimate of the large population. We are selecting few people, like if we want to take the sample of 1,000 people, million peoples, and we are taking a sample of 1,000 or the 100 people. So the sample, it estimate or it describe the whole population. That's why the chosen sample should always be fair representation of the entire population. When we are taking the sample, it's important to consider how the sample is chosen, right? For example, a lottery system could be used to determine the average age of students in a university by sampling 10% of the students' body. Now, let's move to the importance of sampling, because sampling has several importance in statics. First is the cost efficiency. Why cost efficiency? Because studying an entire population, it is impractical, or sometimes it's impossible, and it is also cost prohibitive. So sampling allows us to gather the information from a subset of the population, and it would reduce the time as well as the resources required. Time efficiency, because if we are taking the sample from a very large population, so it also save the time. Feasibility in case where the population is very vast or it is difficult to access, so sampling provides a practical way to collect the data without challenges with studying the entire population. And the main thing is statistical inference, that is where conclusion about a population are drawn from the analysis, right, to predict or to test the hypothesis and estimate population parameter. Practicality, sampling allows to work with the manageable data while drawing the meaningful conclusion. Generalizability, if a sample is carefully selected and representative of the population, the findings from the sample can be generalized to the entire population. And it also reduce the variability and the resource conservation, because the limited resources such as manpower, financial resources can be efficiently allocated when working with a sample rather than the entire population. So basically sample, we should take the samples wisely because it is representing the whole population. The last question, it's what are the different sampling methods commonly used in statistical inference? So, as we already know, what is sample, and this picture also define sample in a clear way. This is the population, very large and difficult to investigate. So, we have taken a small portion and it becomes sample, so it's a part of population. Now move to the different sampling method. So basically sampling method is probability and non-probability. So probability has simple, random, systematic, cluster and stratified types, and non-probability is snowball, quota sampling and convenience sampling. So, what is the difference between probability and non probability sample? So, probability means where each and every element of the population has equal chance of being selected, because probability sampling, it's also known as the truly representative of the population, because each and every element in the population has equal chance of being selected. And non probability, in non-probability, all elements don't have equal chance of being selected. That's why there is a significant risk of ending up with non-representative sample which does not produce the efficient result. Now move to the probability sampling type. First, it's simple random sampling. As the name suggested, it's a simple random sampling. So what we do, so every individual is chosen entirely by chance, and each member of the population has equal chance of being selected. So we are selecting the samples randomly. Suppose I have taken 2, then randomly I have taken 13, then 18, then 6, then 10. We can choose any random sample from the population. So the big advantage of this technique is it is the most direct method, but it comes with a caveat that it may not select enough individual with the characteristics of interest. So simple random means selecting the individual from the population randomly. There is no order. Now second is systematic. Systematic means selecting the individual systematically after a period of interval. So in systematic sampling there is a word sampling interval is also there. Okay, suppose we have begin with the person number 3 and we want the sample size of 5, total sample size 5, and it started from 3. So the next individual that we will select would be the interval of 20 by 5, and 20 by 5 means 4. So after every fourth interval, we will be choosing that particular individual for the sampling. So the third, and then after 3, the fourth will be 7th, and then the fourth will be 11, then the fourth will be 15, and then the 19. So it's a systematic because we are choosing the sample after a certain interval. Because systematic sampling is more convenient than the simple random sampling, because we are choosing the sampling after a fixed interval. Next, move to the stratified. The meaning of stratified means the sampling, dividing the population into the groups based on the gender and based on the category. Suppose 100 people are there and we are dividing the sample on the basis of gender, like 50 male or 50 female, and then we are selecting from that particular subgroup. So basically what happened in the stratified sampling, we divide population into subgroups. Suppose we have in all of these, but we are doing based on the color we are dividing. So first choosing the red color, so 1, 7, 13, 15. Then the yellow color to 5, 12, 10, sorry 90, then green color, and then blue color. And we are choosing, selected the individual from their number, and we use this type of sampling when we want representation from all the subgroup, right? So we have divided the population on the basis of color. First red color, then blue, yellow, then green, and then blue. And now choosing sample. Next is cluster sampling from the probability. Now cluster sampling means we are making group from 1 to 4. We have one group, 5 to 6 one group, 9 to 12 one group, 13 to 16 one group, and then 17 to 20 one group. Now what we will do, the population we have divided into the cluster means into the group, and then randomly we are selecting to be included, like 5 group we have divided, and suppose we have selected fourth group in our sample. So basically this type of sampling is used when we focus on a specific reason or a specific area. Now move to the types of non probability sampling. As I told you, in non probability sampling there is no equal chance of selecting each and every individual. So first is convenience. As the name suggested, according to the convenience of the researcher. Let's say individual number 4, 7, 12, 15, and 20 want to be part of our sample. And hence, we will include them in the sample according to our convenience. Second is quota sampling. Quota sampling means this is also biased, right? Because we are choosing the sample based on the predetermined characteristics of the population. Like we are considering we have to select an individual having a number in multiple of 4, right? We are choosing the number in the multiple of 4. So we are choosing 4, 8, 12, 16, 20. So in quota sampling, what happened? The chosen sample might not be best representation of the characteristics of the population that were not considered, right? And then we are having judgment. Judgment is also known as the selective sampling. It depends on the judgment of the expert when choosing whom to ask to participate, basically. Right? Suppose we are taking 1, 7, 10, 15, and 19. They should be considered as the example. So, as we can imagine, quota sampling is also more prone to bias by the expert, and that may not necessarily be the representative. Last is the snowball sampling. Snowball sampling is basically, I like this sampling technique because existing people are asked to nominate further people known to them so that the sample increases in size like a rolling snowball. Like, suppose I know some people, okay, and I am referring something to these people. Like, I'm the existing sample, and I'm nominating other people to be part of the sample. So this method of sampling is effective when a sampling frame is difficult to identify. What we have to do here, randomly chosen person one for our sample. Suppose it's me, chosen for the sample, and then I'll recommend person 6, and then person 6 recommending person 11, and then so on. So there is a significant risk of selection bias in snowball sampling, as the reference individual will share common traits with the person who recommends them. So this is all about the statics capstone project. Thank you so much for having me.